So I'm Jackie Dixon. I'm at the University of South Florida. Only right now I'm in Canada in the snow. So um, I am a recovering dean. So I was dean for 20 years and stepped down in 2020. Then there was COVID, and I'm getting started in my research career. I call myself a very old early career scientist at this point, trying to catch up from all the research I missed for the 20 years in administration. I'm working now with a group, Armand Huskelson, Fernando Martinez, Pete Barry, and Michael Bismus. And we submitted a proposal in 2022 and then resubmitted it in 2023. It got funded in 2023, but the cruise has not yet happened, and I'll talk more about that. So looking further south from the V-shaped ridges south of Iceland, we're proposing to look at volcanic small seamounts south of the Bight fracture zone. And the Bight fracture zone is a very important both tectonic and geochemical boundary. And it separates, and I'll disagree with Stephen, that I do not believe that the V-shaped ridges and troughs extend beyond the Bight fracture zone. And so we will be looking at this area south of the Bight. If you look at the various aspects of both geochemistry and geophysics that are separated by the Bight fracture zone, there's a difference in rifting style. So north of the Bight is oblique spreading with no transform offsets. South of the Bight, it's regular slow spreading mid-Atlantic ridge with orthogonal spreading with transforms and non-transform offsets. Crustal thickness south of the Bight is normal oceanic crustal thickness. Axial volcanic ridges are right stepping on echelon axial volcanic ridges north of the Bight with linear axial volcanic ridges south of the Bight. A really big one is the presence of gravity lows, so mantle Bouguer anomalies. South of the Bight, there's a huge MBA bullseye that I'll show you, whereas north of the Bight, they are absent. V-shaped ridges are the big characteristic north of the Bight. They are absent south of the Bight. And in terms of geochemistry, north of the Bight, there are two very separate geochemical ridges. North of 61 North, the geochemistry is characterized by varying proportions of an Icelandic sort of high mu component. South of 61 North, really that very little of that Iceland component is present, and it's more of an EM1. So with two separate isotopic components that are present north of the Bight. And south of the Bight, it's we still have the EM, but it's more heterogeneous. South of the Bight, there's also a very anomalous, extremely high depleted, so high epsilon hafnium that indicates an old, extremely depleted component just south of the Bight. And in terms of water concentration, which is what I do, north of 61 North, there's a steady increase in water concentration, and it's variable south of that. So the work that was done by Dick Hay, Fernando Martinez, and Armand Huskelson in 2013 and 2019, they collected, using the Langseth, high-resolution magnetics, gravity, and bathymetry data. And two very interesting things south of the Bight came out of that data. The first is the presence of just a huge number of these small seamounts south of the Bight. So on the left-hand side, you can see all the little dots of these small seamounts. They, for the most part, are unfaulted and appear to be young. On the right-hand side is the image of the large MBA bullseye gravity anomaly. That's one of the largest on the oceanic system. When you look a little bit closer at the seamounts, there's just a very high density of seamounts, and it's anomalous for a slow spreading ridge. And if you look in more detail, we've counted 792 of these small seamounts. They range from about 100 to 600 meters high. Their diameter is about 1 to 5 kilometers in diameter, and they have varying morphology. They're cone structures. Some of them are flat-topped. Some of them have steep edges and are conical, and many of them have small calderas. We've done some preliminary statistical work trying to investigate what are the major controls on the seamount density. And so Armand had a student that counted the seamounts and has done a kriging analysis in ArcGIS Pro. And with that, the contours of seamount density, just looking at it by eye, it seems that they are associated with the boundaries of the MBA. And in addition, there are some isolated structures which may indicate isolated upwelling. We've done another analysis, statistical analysis, using the random forest method, which allows a ranking of the various geochemical variables that could influence the seamount distribution. And when we do that, the MBA is the variable that explains the largest proportion of the observed density, about 34%, with the other variables being less than 20%. So we gridded the gravity, bathymetry, backscatter, and magnetic anomalies. This is work in progress, and hopefully we'll have a paper by this spring. So intrigued by the distribution, abundance of seamounts, their young age, and the association with the MBA, we got a proposal funded through NSF, and the PIs are myself. I'll be doing major elements, trace elements, and volatiles. Mike Bismuth at the University of South Carolina will be doing radiogenic isotopes. Pete Berry at Hui will be doing noble gases and nitrogen. Armand Huskelson will be involved in the physical volcanology, and Fernando with geophysics. And I'm also working with Bramley Merton on completing some of the geochemical analyses that haven't been done on the existing sample suite. The goals of our proposal will be looking at geochemical compositional variation across the MBA transect. We'll be looking at magmatic accretion differences across the Bight transform fault, and what exactly controls the seamount distribution and abundance, distribution of mantle components. Do we see any Icelandic geochemical components south of the Bight, or is it all just reflecting the heterogeneity observed in the North Atlantic surrounding the Icelandic influence? And the role of volatiles in volcanic morphology and eruption dynamics. We'll be looking at, I think, about 10. Hopefully, we'll be able to sample about 10 volcanoes and 4 axial rift sites in the vicinity of the Bight. We will be using AUV Sentry for high-resolution multi-beam mapping and magnetics. We'll be using the ROV JSON for in situ sampling. So for each seamount, we'll do the high-resolution mapping with Sentry and then go back in with JSON to do in situ sampling guided by the Sentry maps. We will be on a global class vessel. I don't know which one yet. We are not yet on the ship schedule. COVID keeps coming up in all the talks today. So last year, NSF has finally cleared out the backlog of cruises caused by COVID delays. They wanted to, it was possible that I could have gone out this summer, 2026, but it would have been in September. And I said no. So I'm being very adamant that if we're using all this fancy equipment that requires good deployment conditions, I want to make sure we're going out in the good weather window, which really is sort of end of May through the end of July. And Stephen, you might have something to say about that. I don't know. So we're doing our best to stay busy while we wait to get on the ship schedule. There are opportunities for collaboration. One is I have funding for 2 years of a postdoctoral position, and that postdoc will be doing a lot of the major trace and volatile geochemical work. I don't want to start searching for that postdoc until I know when the cruise is going to run. So as soon as the cruise gets on the ship schedule, I will be searching for a postdoc. So if you have students that are finishing up that might be interested, keep me in mind. Sediment cores, we will have the opportunity to take gravity cores when we're deploying the other equipment or in between deployments. That is not in the proposal. I've proposed to do push cores from Jason. So when we get our basalt samples, I'll also be getting small cores, push cores, but we could also do gravity cores. So if anyone is interested in adding gravity cores, Bramley Merton tried to do a proposal to get that funded through the UK, and it wasn't funded, but that's an opportunity for additional collaboration. In addition, hydrothermal, I thought about putting a hydrothermal person on the proposal, but it was already big enough. We can put a hydrothermal sniffer on the Sentry deployments. I'll definitely be doing that, but I don't have anybody involved to analyze that data. So another area for potential collaboration.